G'day guys, how you going? Next video in our RPA guide is looking at the Fieldwork RPA. And I do have to apologise, my hair is a little bit COVID crazy today, so you'll just have to put up with it. The classic RPA structure, what are we investigating, what is the method, and what would you expect to see? This RPA is going to be divided into two sections, kind of looking at how we sample an environment with quadrats and how we sample an environment with transects, okay? So we need to know what these things are, right? So this is a quadrat. It's a square, fancy name for a square. You drop it on a field and you count how many daisies or whatever species are inside of it, right? That's what you do. It's a great technique because it means that you can sample an environment much quicker and much cheaper, all right? If you weren't listening to me there, well, when do you need the too long didn't read is if you want to know how many of something there are but can't really be bothered to count them all, use a quadrat, right? It saves you a lot of time and a lot of effort. So it's perfect for my students. For a transect is actually this red line here. It's a line that you run out across an environment. So you run it over an area that changes. Maybe it goes from shady to light or from wet to dry, whatever it is. And then you put quadrats along this transect at regular intervals and you count out how many species are in them and you look at how it changes as you move along the gradient, okay? If it was too long and you didn't read that, if you want to know how many of something changes over an area, you use a transect with quadrats, okay? So if it's changing, quadrats. If you're just trying to sample an area, just use quadrats. All right, so the first question that we're going to ask today is how many daisies are in the field at school? The variables, the independent variable, the one we change, is the quadrat's location on the field. The dependent variable, the one we measure, is the number of daisies in each quadrat. So how do we do it? There's the stunning field. Step one, you select the area you wish to sample, for example, the field at school, which is what we've got just here. Step two, we randomly locate at least 10 quadrats in the field, best done by dividing it into a grid and random number generator as I've got here, but you can close your eyes, spin around and hurl it, not like a ninja star, don't decapitate your friends or anything like that safely, all right, but you can throw it somewhere random within the environment. So here are some random located ones that I did with a random number generator. Step three, all you need to do now is count the number of daisies in each of these quadrats, right? And stick them in a table. Okay, so this is what you would have. You would have, once you've done that, you would have something like this on the left. Which quadrat it was, how many daisies were in each quadrat. It's time for a little bit of maths, guys, sorry. So let's calculate the mean number of daisies per quadrat. For those of you that remember, we just need to add up all these numbers and divide by how many numbers there are. Okay, so this, if we did that, we added them all up and divided, we come to 1.4 daisies per quadrat, which is just there. Well done. So now then, how many daisies are actually in the field? Well, if we've got 1.4 daisies per quadrat, we need to know how many quadrats would fit in the field. In this case, I've counted up all my squares and 170 quadrats would fit in the field. So let's move over to our calculation space and have a go. So if we have 1.4 daisies per quadrat, we would have 170 quadrats to fill the field. All we do is we take the mean number per quadrat, multiply it by the number of quadrats, which is 1.4 times 170, which means we would have 238 daisies in that field. And that has saved you so much time and effort doing it this way than it would have to actually go out and count all the daisies. So we can spend a lot more time doing maths in class instead of boring things like being outdoors and enjoying the sun. Okay, so this brings us to our second question, which is kind of looking at a transect. Well, all right, how does the number of daisies change from the shady part of the field to the sunny part? So the independent variable, the one we're going to change, is the quadrat's location on the field, whether it's in a shade or in the sun. The dependent variable is the number of daisies in each quadrat. Here we go. So what we'll do is step one, we'll look at the field and we'll run a transect out randomly along that field. Boom, there's my transect, right? With the gradient. So you can see it's going from the shady environment here to the sunny environment over here. Step two, we put quadrats out at regular intervals. Quadrat, 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 perfection. And step three, we would just go through and we would count the number of daisies in each of those quadrats and put this into a table, which is what I've done just here. You can see of those 6 quadrats, we've got 2 here which were in the shade. The first 2 were in the shade, as you can see, and the next 4 were in the sun, okay, which is what we've got in our table just here. So number of daisies. So we count calculate a mean for the shady environment. So the mean number of daisies in the shady environment was 0 plus 1 divided by 2, because there's two numbers, which is 0.5 daisies per shady quadrat. So let's work the mean number of daisies in a sunny quadrat. So the mean sunny is mean 0, 2, 1, 2, add them all together, which is 5, divided by 4, which is 1.25 daisies per sunny quadrat. And what you can see is by running out this transect and comparing these two environments, we can actually see that in the sunny environment, there were more daisies per quadrat, probably because they could do more photosynthesis and survive better by making more glucose, etc. And those are the two quadrats, those two fieldwork, these two sections of the Fieldwork RPA. Hope this helped, guys. I'll catch you later.